Hi, welcome everyone. Let's go ahead and get started. So welcome. I hope everyone's enjoying Build so far. I hope everyone enjoyed the keynote. Got to see lots of cool stuff today. So welcome to the last session slot of the day before you get to go out and enjoy some of the wonderful restaurants in downtown Seattle, go to all the cool after parties. But before that, we're going to have a quick talk. So we're assuming that you're here today because you know that enterprises need data. They need insights about physical spaces. And that you, as developers, are being asked to put mixed reality capabilities into your apps. So how do you do that in a seamless way, in an easy way? So that's what we're going to talk about today. I'm James Nance.
I'm Omer Rosenbaum.
So thanks for joining us. Our goal today is when you walk out of here, you will be inspired to join our developer community and get an early start on developing products based on our new spatial analytics service. So before we get too far in, I have a quick confession, quick level setting. There will be no HoloLens or mixed reality applications really shown today. So if you came today expecting lots of holograms, I will apologize in advance, and no foul if you sneak out the back. But we are showing something new. We're showing spatial analytics for mixed reality. We have a reference device today we're going to show off, and we've got some cool demos to look at after a while. So while there are no holograms, we are building on the promise that HoloLens started of giving computers perception and understanding of the real world. So why should you care about spatial analytics? Because it answers the question, what is happening in this space? And that insight is valuable to customers. So let's see some examples from one of our customer engagements.
At ThyssenKrupp Aerospace, we partner with the world's leading aerospace companies to simplify their supply chain management. We have a complex flow of materials in our factory to keep production running smoothly.
Our top priority is keeping people safe and making sure they have access to all the tools and information they need to make better decisions quickly.
Microsoft's mixed reality tools are helping us get there. As we take on new projects, we need to optimize our workflows. With Microsoft Layout, we're able to make design changes in our actual factory space with 3D holograms.
Once we have an optimized workflow, we use spatial analytics to help drive quality improvements. We're running 24/7 on most saws, so it's expensive to take one offline. Spatial analytics listens to our machines and helps to tell us the right time to replace a saw blade, balancing quality with the bottom line. One of the most stressful things in our business is when a customer calls to tell us they have a grounded plane waiting for a part. We have to drop everything and get that part out so the plane can get flying again. We need to move fast since it affects all of the other orders in our pipeline.
Cortana, what 14-foot saws are available?
Cell 14D is available.
Cortana, tell planning that I'm moving to cell 14D.
Integration with Teams and Cortana allows our workers to make quick, in-context decisions that speed up production. No matter how fast we're moving, we need to deliver the highest quality products every single time. When we finish an order, it's important to document the condition it was shipped in.
Spatial analytics helps us with the quality assurance process. We can store time-stamped information and photos about our work orders for future reference. With Microsoft's mixed reality tools, we're able to work faster, safer, and at a higher quality than ever before. We can't wait to scale this across our entire organization. There's so much possibility.
So hopefully that gives you an idea a little bit of what we're talking about. Spatial analytics are valuable to enterprise customers because they allow them to make better, higher confidence decisions. It lends consistency and predictability to their workflows, and it helps their workers to stay focused on moving people and products through physical spaces. Now, solutions like this are not easy to make for developers. You're expected to be a hardware expert. You've got to design your own hardware, put the right sensors together, do all the compliance, the security, the enclosures, and then figure out how to take it to scale. You got to be an expert in the cloud, so build your own cloud store, get the data ingested correctly, ideally enrich it in the cloud, and then make it available. You've got to be an expert in your app development, and ultimately in your customer to make them happy. Now, you could be good at more than one of these things, but it's difficult and expensive to be good at all of them. Our approach has been to remove a lot of these gaps by creating an end-to-end solution and creating some easy touch points for you to engage with. As you create products, it'll be easier, faster, and cheaper to build the things your customers want. So before we dig in and see how the tech works, let's agree on some conceptual, foundational concepts. Everybody loves definitions, right? This will be fun. Let's start with spatial. Spatial is a confusing term because it's very overloaded. Most of the time when I say spatial to people, they think about devices that understand where they are in space or relative to other devices, that they're geolocated somehow. What's interesting here is thinking about spaces as the subjects or even the owners of data collection. By giving computers, IoT devices, perception and understanding of the real world, it creates power, it creates that perception understanding, right? And we call this collection of capabilities spatial analytics. As I mentioned earlier, it helps answer that question, what is happening in this space? And more specifically, how is my space being used? And is this space comfortable for my customers and safe for my workers? Making mixed reality native apps, they're more powerful when they have a real-time connection to people, places, and things because it enables degrees of interaction between digital content and the real world. Context is key. Context is valuable. Apps and services that are context-aware can provide valuable information to customers. It makes the information relevant to their workers. But how do we make apps that are context-aware? We need these things. We need an actor, something to make something happen. Who did the thing? We need an action. Something has to have taken place, so what happened? We need a when did the thing happen? We need a timestamp. And we need a location. So where did this thing happen? Data that it's ingested into our spatial analytics cloud service has all of these elements. So when you develop apps using this service, your apps are naturally context aware. First-line workers, you may have heard this mentioned in the keynote today, maybe you know the term from before. Who are first-line workers? We're talking about baristas at maybe a large coffee chain, workers on automotive assembly line, warehouse staff, front desk clerks at the hotel. These are your end users. Tech companies like Microsoft have focused for a long time on people in offices, in conference rooms, using PCs to get things done. But we see a huge opportunity in building productivity tools for first-line workers. There are over 2 billion of them in the world, and a lot of them work in spaces where they don't have access to PCs, and they are not allowed to use their smartphones. You guys know what IoT is. I'm not going to explain this to you. There are tons of devices already in the market. But if you're gathering spatial data, which I assume is why you're here, you don't have to care about all IoT devices. So when you're thinking about what's useful as a data collector, it's helpful to focus on devices or data collectors that are autonomous, so they can function without human oversight. You want devices that are contextual, so they have that awareness of who, what, when, and where, like we talked about before. You want data collection that is insightful, so it's delivering a deep understanding of spaces that helps your apps automate repetitious tasks. And we want unique data. We want data that's differentiated because that's the most valuable kind. Another term maybe you heard from the keynote or have been familiar with, what we're really talking about here is processing that's offloaded from the cloud to IoT devices. And why do we care about this? Well, if you think about all the IoT devices, all the connected devices in the world, all the ones that have sensors, it makes sense to to process data locally whenever you can for reasons of performance. Maybe you don't want to cloud up your network traffic, or for privacy reasons. So if you're collecting audio data or video data or pictures, you maybe want to process that before you send it up to the cloud for privacy. And the cool thing about intelligent edge devices is you can develop apps, machine learning models that run on device that process and enrich data before it's sent to the cloud and ultimately the customer. You guys know data. Raw data is easy to collect, hard to make sense of. You can collect mountains of data. You can drown in data. But when you structure it, when you put it in context, it can drive action. And we'll talk more about insights in a second. But typically, we see data organized into 3 buckets. You've got public data. This is data that's available to everyone. It's things like census data, traffic data, things like that. Anything that's publicly available on the internet. You've got user data. This is the type of data telemetry you've been collecting on users through websites and applications the whole time to understand what your customers are up to, and that kind of funnel and that flow through your experiences. And then organizational data. So this is data owned by organizations about organizations. And so when we're developing solutions with spatial analytics, what you really care about is data about spaces. More specifically, telemetry. So fast-moving data, time series data. And this data is spatial because it's about what's happening in a space. And this is coarse data. Coarse data is still valuable. Things like temperature, humidity, light and sound level. How many people are in this room? What was the foot traffic flow through here? How long are people waiting in line before they have to order their coffee? All these things are simple insights based off simple data, but they're extremely valuable. So how do you get all this data into your apps? That's right, Microsoft Graph. So what we really care about here is the Microsoft Graph API. Before this API came around in the old days, if you wanted to get data from a bunch of different sources, you had to make different endpoint calls to all the respective services. It's a pain in the butt, it's complex. But the Microsoft Graph API is a unified REST API for Microsoft 365. It used to be called the Office 365 Unified API, for anyone who remembers that. But what you guys care about is this is a single endpoint for all of your data in the Microsoft Cloud. It's one endpoint, one auth token, one set of docs you have to onboard, and one SDK. So it's a one-stop shop. It's easy to get your data. All in the service of this. Insights are the payoff. This is the product that customers want. Now you want to help your end users, right? These first-line workers. They have these icky parts of their job they have to do, these repetitive drudge tasks that they have to do. Insights can help. Your apps can help. You can take the things that computers are good at, like counting stuff and tracking stuff, and help automate that part of a first-line worker's job, and let those folks do what humans are good at, creative problem solving, communicating with other humans. And this frees up their time to do more useful things for the business, to push the business forward. And we talked about there's lots of data in the world, tons of data, we're drowning in data, right? Well, these workers need intelligence they can act upon. You can't act on raw data, whether that's trying to plan how much staff you need in your coffee shop or make the best quality products that your customers want to buy. If you can't interpret data and it doesn't result in action, then it's a waste of time. It's useless. That's why insights are so important. So let's take a look at the tech that helps us get to these insights. Everything starts in the Microsoft Cloud. We started by integrating off-the-shelf Azure IoT services because we wanted to take advantage of existing infrastructure, security, and privacy that these services already bring. We've got IoT sensor devices that collect coarse data in the world and ingest this data to the cloud. And as I mentioned, there are two types of devices we think about. There are light IoT devices. These are typically microcontroller driven. They're simple things like a smart button or a thermostat. They don't have to do any processing to the data before they send it up to the cloud. And then there's things that we consider heavy IoT edge. And these have extra processing power on the device. They can run containerized apps, and this is an opportunity for you guys to develop apps or models that run on device to enrich that data before it's sent to the cloud through something like IoT Edge. And finally, once the data has been processed into insights, it's got to show up somewhere. And our approach has not been to go develop an app because everything we've heard from customers is they don't want another app. They've already got apps how they run their business. So our approach is thinking, if we build some smart integrations, if we can show up on things like voice assistants, PCs, smartphones, HMDs, then we can be useful at bringing these insights and data into context. And so there's an opportunity, obviously, there to do these integrations and to build your apps and put these capabilities into your UWPs. If you're a cloud developer, then of course you can take advantage of all of the existing Azure services just like we did to make spatial analytics available. Now that's probably most of what you need to know to get started, to be honest. But we're at Build, so we're going to take a little bit of a look under the hood. So we're going to start with an IoT device. There we go. We've got a device stack. We've got all the hardware, the sensors, the system on module, all the stuff that makes the hardware work, the power, all that stuff. We have the bootloader. This is the thing that actually boots the device up when you put it on and usually puts it into some kind of provisioning mode so you can get it up on the internet. We have the operating system, the drivers that pull all that sensor data together and make them work and play well together, and some kind of a runtime. And on simple devices, this is it. The runtime helps connect to the cloud and ingest that data. On those more complex data, we have something where you can run a container app on the device through IoT Edge. The data is ingested to the cloud through a protocol called MQTT, which is Message Queuing Telemetry Transport. That is a thing I know now that I did not know before. All you have to care about here is it's secure, it's reliable, and it works with the majority of IoT devices. We can ingest data through IoT Hub, and we can use things like Azure Stream Analytics, Azure ML, and Azure Functions to move the data around, store it securely, and enrich the data. And then we've built a couple of things of our service to do notifications and alerts on top of data and build insights, because as you've been, specifically predictive insights, as you've been collecting data about a space for a while, you can begin to detect patterns. And so notifications are great for things like anomaly detection. So if it's very, very loud during the day and then very, very quiet at night, perhaps if you're a shop owner, you'd be interested to know if it's noisy in your place of business at 3 a.m. This is a simple alert we can send out. And then predictive insights, if I run a pub and I probably have a pretty good sense of what my foot traffic's going to be, but maybe after watching it for a period of time, it would be useful for me to know that a ton of people are probably going to come into my shop next week because maybe there's a Seahawks game in town, maybe they're projected to win, and maybe everyone goes drinking after that. And so I might want to lay in a few extra kegs and some beer pretzels and some staff so that my customers have a good experience and I can take advantage of that opportunity. Finally, these endpoints we talked about. So again, this is about making this data available in context and respecting the processes that your customers already have, because they've spent a ton of time and money training their staff. And if you can show up, again, these voice assistants, messaging apps, things like digital signage, or whatever UWP your customers already use, they will appreciate that because you're not asking them to onboard a new app or retrain their staff. Data can be pushed through any type of workflow, so things like Microsoft Flow, Zapier, if then that. And this is super useful because it gives you the flexibility to affect the real world, to react to information with automation. So simple things like if it becomes really loud in my restaurant, maybe I want to turn the music up, or maybe I want to turn the music down before someone calls the fire marshal. And then finally, Microsoft Graph. As I mentioned, all of this data is available through Microsoft Graph. It's a one-stop, single endpoint, single authorization for all your data. Very easy to get to. So great, let's talk about some specifics on what you can actually do with this technology and why it's valuable to customers, why somebody might pay for this. So when you're thinking about spatial analytics solutions, when you're thinking about your apps that you're going to develop, might be helpful to have some straightforward design goals that could be helpful as you plan this stuff out. So when you're designing an app or a model or an end-to-end service, please ask yourselves, are you helping your customers understand their business better? Can you help them reduce operating expenses, increase efficiency or throughput, or improve worker safety? All these are things they will pay for. Can you help them see problems and opportunities before they happen so they can get ahead of them? Again, with these predictive analytics. And then, what about their existing processes, like I talked about? Are you asking them to throw those away, all the time and money they've invested in training, or can you find a way to integrate into how they already do business? And then finally, to kind of reduce friction of adoption, can we find a cheap and easy way to install these and get them integrated so that your customers see a very quick return on investment and you get good customer signal back? So a lot of these IoT devices are not super expensive. They're easy to integrate with the cloud service. And so through Microsoft Graph, we hope that they're easy to integrate in your apps. So we hope that this is an achievable goal for you when you're thinking about your solutions. Now, when you're planning out how to collect data, it might be helpful to think about this framework of giving senses to spaces, because that will help you pick the right sensors for the job, the right devices for the job, and make either your on-edge models or your end-user apps more useful. We think of things as hearing, sight, and touch. We could do smell. There are chemical sensors that do smell. But those tend to be a bit more expensive and kind of rarefied use cases. But these light up a lot of interesting scenarios. So hearing could be something like a smart connected mic array. We have one that we're going to show today, and we have one on display in our booth in the expo floor, which we invite you to come see. Doing things like sentiment analysis. Again, that maybe large chain coffee shop is very interested in understanding if their customers are happy or grumpy. And at what point during the day that occurs, and how that correlates to their buying habits. Environmental comfort and safety. As I move through a factory floor and I approach loud machinery, it might be great to give me a heads up to put my hearing protection in before I start getting into a safety problem. Activity ID and anomaly detection. So being able to use smart microphones to understand what's happening in spaces and send alerts based on that. This could be what we showed in the video of I'm running a saw cutting titanium or aluminum. That saw starts to make a different sound as the blade gets a bit duller. And so I can send a notification to do preventive maintenance on that before it begins to affect the quality of my products. Sight, this is basically computer vision. This could be RGB, it could be thermal. But again, understanding in my retail scenario potentially, how are people coming through my store? When they come in the front door, do they turn left? Do they turn right? Where do they stop? Where do they engage? That's going to help me place end caps and sales and signs and where to position my staff. When I'm thinking about factory floors, maybe I want to send an alert when people wander out of the lane and into the traffic flow of the forklifts and cranes. Engagement in queue times. Again, how long am I waiting before I place my order before I leave? And then touch. Touch is an interesting one. We think of this as like smart buttons. Eventually, computer vision will get good enough to where we can just figure out everything that's happening in a space. Although we have to figure out the creep factor on that. Thermal helps a bit, but RGB cameras, people get a bit nervous about sometimes. But what we could do with buttons that's super interesting, smart connected buttons can start to capture user intent and context. You can capture timing and frequency of pieces of a workflow through a digital connected button. And this button can be pretty useful to your first-line workers because anytime they would have to stop what they're doing or stop making a thing or interacting with a customer to go talk to someone or to go get help, instead they can hit a button, whether that's, hey, I'm in the back, I need more lettuce, or hey, I'm on a factory floor and I just finished making my product and I want to update my metrics and statistics. So these can fire actions or they can send messages. And Might be helpful because it's what we're thinking about, and it's kind of food for thought for you guys, but these are industries where we see a lot of opportunity initially. These are industries that are undergoing rapid digital transformation. So they're moving their analog processes to more digital ones. They have lots of process, lots of automation already, and a lot of them have expensive equipment that they've invested in that they want to be able to do predictive maintenance on, and they want to be able to understand when these things break down because they're mission critical. And when their lines shut down, it costs them money. And so these might be useful to think of as a filter, again, for kind of what capabilities you put into your apps and your solutions using spatial analytics. And so, again, these pain points, if you're looking at intelligent warehouses, can we do increased predictability? Can we have better throughput for these places? Improved safety is good for any industrial. For retail, can we reduce operating expenses or improve the customer experience? And how do we increase their revenue? These are all things customers will pay for. So that's enough of me talking. We're going to show you some stuff. So I'll turn it over to Omer.
Thank you, James. A few minutes ago, we saw a video of a factory floor that has many saw machines. Those saw machines are running 24/7. Any machine that is taken offline is losing money. What if we could use IoT devices next to those saw machines, detect the pitch of a saw as it gets in different pitches means that it might be getting dull. We created this device and we integrated that in a factory floor with ThyssenKrupp. So here's the device. It's still running, so that's good. Now, we have a slightly different scenario here where this device is running IoT Edge, a machine learning model that is detecting a sound of a saw. Let's see it in action. All right, so we created a chatbot running on Microsoft Azure. It can run LUIS, the language understanding internet service, and it's integrated in Microsoft Teams. So in order to demonstrate that, we tried to bring a saw machine here, but it was not really practical. And the problem is that we said we wanted to bring a power tool, but a software engineer and a power tool on a show stage, didn't really work with some people. So James and I did the next best thing.
You can't type in these, so don't put your...
I know, yeah. All right, let's take a look. We have a very expensive saw here. Here is Microsoft Teams. I'm logged in. I've installed the Spatial Analytics bot. Let's say hi. All right, let's list my devices. All right, let's rename one of the devices. As you see, we have 2 devices. I wonder why for a demo.
Yeah, those aren't the best names. What are you going to call it?
I like Masha and Bear, the show, so I'm
All
going
right.
to call it Bear. All right, let's see how Bear is doing. Oops. All right, looks like it's alive and running, so that's good. Let's see what's the last event Bear heard. Okay, no data, so that's good. So now, let's try to convince
Safety
Bear
first.
to hear something.
So we're showing these simple commands with a bot framework. So you can imagine how easy this is to configure and test out these devices.
You ready?
Yeah, let's do it.
Okay. see what happened. Forgot my ear protection. So as you can see, Bear just detected a few seconds ago the sound of a saw running. We can take that, we can aggregate all the time it was running the last 30 days, cross-reference that with manufacturer specifications, for instance, and recommend a replacement of a saw blade. We can take a look at the data from Bear. So inside the raw data, we also have the dB level. And we can do an histogram, for instance. Histogram. 7 days. All right. So up until now, we were querying the service. How about we set up an alert so whenever Bear hears a sound, we can get it right into Microsoft Teams. So let's go create a new channel. For a channel, we can create a connector. And we set up a webhook. Let's configure it.
I didn't even know some of these tabs existed in Teams.
Let's get some image. All right, so let's copy the webhook URL. So, by the way, with a webhook, we can actually send messages to a channel from outside without being logged in. All right, let's register alert. Okay, device name, Bear, alert webhook. All right, and just a second, let me go back to the channel. Okay, we set up a connection, that's good. And let's see if we actually get an alert. All right, we can see the device alerted us that the saw was running. And you can imagine this is Azure IoT running an ML or CNN model that can detect any classes of sound, so we can identify whatever we want and ship it to Azure and cross-reference with whatever other third-party services in order to send various alerts. OK, so enough with Teams. Let's take a look at a little bit code. So I've got the test method here in a sample app. So first, let's take a look at the test method. Basically, what I've created here is an integration with Microsoft Graph and showing that utilizing Graph, we can grab some sensor data and people data and merge them together. So here you go. We have authentication with Active Directory. We are getting we are authenticating with the Microsoft Graph. And here you go, we are connecting to the Spatial Analytics endpoint, getting some device data, getting the sound level, and then sending an email whether the sound level is above 90 or not, so decibels. So let's put the breakpoint over here. Just run it for a second. Can probably take this off. Ah, OK. I ran the sample app instead of the test, but it's okay. We can take a look at the sample app. So the sample app is basically doing the same thing. So we are querying the devices. We actually have a show floor with all the devices. We're querying their decibel level, and we can contact the manager and send an email through Microsoft Graph. And also, we can represent this visually and look at some history.
We have a version of this working in the expo floor on display. So if you come to the mixed reality area of the expo floor, you can actually see this with a heat map of all the booths and the noise level that they're generating.
Right, and I'm going to just debug this test that I showed you. Sorry for jumping on the app. So we authenticated with the graph. We went out and reached got my devices, and then have a device ID. And now I'm just about to query the device for the audio level. So, an experiment. If you can make some sounds, let's try to get the audio level above 90 decibels so we can actually send James, my Contoso manager.
Oh, good.
All right, let's make some sounds. Woo! All right. Querying the device. And let's see what is the sound level we detected. 99, that's good.
Nice.
Well done. So now I'm just gonna
That was not just a cheap ploy for applause.
get my manager from Contoso, and yes, let's run it. Let's open Outlook and see what happened. And by the way, this is all through Microsoft Graph. This is not using the local client. Here we go. All right, so as I said before, we can this is only an example of one sensor that is sending data. We can aggregate multiple sensors, multiple data sources, and run Azure Machine Learning behind the scenes. And then what's really exciting for me is we take all this sensor data and combine it with mixed reality. So when I want to see a day, and it's going to come really, really soon, when we put HoloLens on and we go into a place that has many, many devices, we already know what's going on there. And it's almost like we see the matrix. We actually see the area coming to life. Thank you.